So in our previous discussions, we highlighted significance and relevance of space. In this section, we would highlight spatial interactions and how you can express these spatial interactions for bringing new insights and draw inferences and represent the ground realities effectively. That we would try to put before you as to how you can proceed with your data, with your understanding, with your discipline, how you can represent the spatial information. So in this discussion, we would share some examples and we would also try to explain you as to how you can represent the different kind of ground realities which we observe and how we can represent them in spatial information. Now, these examples are drawn from our previous discussions highlighting methods and techniques of space representation. Although theoretically we have already explained you, but now we would try to explain you as to how effectively you can represent your information in spatial form, in digital format. So, spatial representation is simply mapping the ground details, and this is one example which I'm trying to explain to you and will give you as to how you can use it. This is preliminary but effective way to explain and highlight the ground realities. I mean to say simply mapping the ground details. This is the first step for representing spatial information. So there are certain informations which you can map and spatially you can represent. So that is what the basic objective of this particular slide. We can use several sources of data for spatial information. We have discussed at length earlier. And we may start from historical maps to governmental archive records, planning documents, topo sheets, maps, or modern aerial photographs, satellite imageries, previously surveyed informations. All of them we can draw into our study in our representation of spatial information. So in this particular slide, you see, I am drawing information from historical records also. So from there, how the city has evolved. This I am trying to represent through spatial representation. So you see here, this is what the beginning of the city evolution, and this has about 1000 AD years, so that is quite old information. Now this information is in written descriptive nature. I am trying to represent it through spatial information. So I am just giving you an idea as to how you can use the spatial information. So this is some historical records, but I am portraying it into spatial format. So that is what I would say is the advantage of spatial representation. Now you see, with time the city has grown up. We say that this part of the city has grown up. Now I am depicting it in spatial format. So another historical records, but I am trying to highlight it with some spatial representation, with specific spatial representation. So newer areas have come up within the city evaluation, of which the records have been found in historical records. So that have been replicated here in this spatial information. Then further, during pre-independence, how city has grown up. So this has also come up here. If you see in the recent time, in 80s, the city has evolved further. And then you see, this was the historical records. Now, another set of data and another set of spatial representation. Here in this particular slide, here temporal comparison is also possible. When we are using different time period information, for example, in the context of land use of a city, we can make temporal comparison, or in other word, I would say that how the city has grown with time. that we can represent through spatial information. And it's very interesting, and you would find it interesting when you will see that how city has expanded spatially with the help of maps, with the help of spatial information. So one big difference between computer mapping and spatial information mapping is that when we use spatial information, georeferenced information, it brings with spatial representation of the data also. I mean that what phenomena we see, its attribute informations can also be presented in data and statistics. You can see here that how the data is coming along with the spatial information. So that's another important advantage of spatial information science. For example, here you see the temporal land use is shown, but it also gives us area coverage details. That's a big advantage. Now here you can see that you get proportional coverage of land as well as precise change matrix also. So this is, again, I would say, very important advantage of spatial information then compared to, say, computer mapping or any other traditional method, other methods of representing the spatial information. One more important point which I would like to highlight here is the topology. The topology is also visible here. You see point, line, polygon entities in this particular slide. You can bring specific inferences also. What is your observation for this particular land use land cover map of Aligarh city 1980? Now, I would give you another important aspect about it. As I have said in the beginning itself, that we can have the advantage of having temporal information. So here it is 1980. Now you see in 2000 city has expanded. So it is coming like that. And in 2020 it has expanded further. So this is what very obvious. But you see when I am changing the slide, for example, here if you see it is 2000, here it is 1980. So if you look into the statistics, it is changing. Now precisely you come to know, you would be aware from these spatial information as to precisely which land use class is increasing or decreasing. So that's another important advantage. You see, the map is only showing you the spatial representation. But the advantage of spatial information science is that it is not only about the map, but when we have georeferenced, when we have linked the ground details with the map details, it is also representing all kinds of statistics where whatever changes which are happening on the ground, the map, how much area, that will also come into the map. So that is, I would say, is a big advantage of spatial information science. So this is 1980. Now you see carefully the changes. This is 2000 and this is 2020. Now I'll pose one question to you. What is your observation on these spatial representation? Can you find out any specific pattern or trend that you need to look into it? Because that's very important. It's not only about the how the city is expanding, but it is also about which land use class is becoming prominent. It might not be very clearly visible to you in the map, so you can consult the data also. Both of them, they are going simultaneously in these slides. So I would suggest you that think about it, and when you would be able to explain as to how temporal changes have occurred in the city and which land use classes were dominant in the expansion of the city and on which land use class the city has expanded. So that would be very interesting inference which you can draw. During our theoretical and conceptual explanation, we highlighted that in this spatial information, we can provide, using this spatial information science, some new insight. So here I am posing one question, that with this slide, with this information, what kind of inference you can draw. As the obvious inference is that city is expanding, but what other? So that the pattern and trend, if you can bring out of it, that would be good knowledge, execution of knowledge of spatial information. Moving ahead, you see, this was one slide which I have shown you earlier during the spatial analysis. Here, spatial aggregation was highlighted, where I said that it is about adding some information or classification or reclassification of certain classes which is being represented on in any map. So that is what we discussed in theory. Now, how it can be applied to practically when we are conducting some kind of analysis and examination of spatial using spatial information. So you see, the same information which I shared with you earlier about the land use. Now here within these temporal information, I am extracting out by reclassifying the land use classes. I am only talking about now, I am only concerned about now only the built up areas. So here reclassification has been done among the different land use classes. I have clubbed, I have aggregated some of the information for forming the built up area, and these built up area during different time period, how it has changed. This will give me an information, a new insight into the urban growth. So this is also possible, and this is what we have done in this particular slide, which I am trying to highlight. So this is one kind of reclassification and aggregation of spatial information, which we dealt in detail during the theoretical part. Now it is the application of that theoretical kind of spatial query which we are applying over here. Then another is, you see, when we are saying that built up area is increasing in the city, it is at what cost? It is happening on which land use class? Obviously the surrounding area might be, not might be, in this case it is only the agricultural land. So another aggregation and reclassification give me a newer insight, where I am getting this information that how much agricultural land we have lost due to the urban expansion during the study period of 1980 and 2020. It is not only about the spatial information as to in which part of the city the losses were dominant and in which part of the city the losses are not so dominant or lesser, where the prominent losses are happening. But we also know that how exact is the loss of agricultural land. Now it can be used for planning also, that if we are losing out this much of agricultural land, that means that this much of production we are losing out of any agricultural commodity which is being grown in the agricultural area. So this is also one kind of aggregation and reclassification of land use classes in this particular study. And also we are drawing out some inferences which are not visible in the original map if you go to that particular slide. So this is again, I would say, how new insights can play an important role through spatial information. Moving ahead. Now, this is another interesting aspect. You see, out of those land use classes, there was one land use class which was the vacant land. Now, vacant land is something where agriculture is not being practiced, although it is in the agricultural sector. So, I am again reclassifying and using the aggregation of certain land use classes, and I am giving another insight into the land use study which we have seen in the first slide. And I am saying that these are the areas, these are the vacant land. So I can say that these are the areas where agricultural activity has been abandoned by the farmers. So this is again new insight. So we have lost certain areas due to built up expansion, agricultural land we have lost, and we have also land which are not being utilized for in agricultural sector. If I can go in detail, I would give a term of speculative landholding, but it's not of, I do not want to go into the details of how the phenomena is evolving, but I am just giving you that how new insights we can draw from this kind of analysis. Spatial analysis, where we are just putting certain attributes together and bringing in new spatial information and new insight into the study. Now, the city has, out of the total land which is for the city, I have now plucked out only some portion of the city. Now again, it is possible only in the spatial information. So here I have only plucked out the university area, and there I have tried to find out as to how the changes have happened. So this is the land use of Aligarh Muslim University, where built up area has been identified. So this way I can say that you can aggregate, reclassify and use the spatial information in different way, and you can bring in more insight into it. Now, in this particular slide, I have explained at length to you during my previous interaction with you. In these slides, we explained some spatial language about spatial analysis procedures like spread, which is to create a zone of influence around a point, line or area entity. This can be done by drawing distance of spatial positions in the data set. Another is overlay, which is to find the similarities or differences of two different sets of area entities covering the same spatial area. If you recall, we discussed about the irrigation of rice farm. If you recall, this was the example which I have explained to you. So this overlay is done by superimposing two or more sets of area entities over each other to produce a new set of area. Similarly, extract is to extract a new data set from the existing data set. This is done by selecting specified values or class from any one entity to make a new spatial entity. So now some examples from real world study and its application. So this slide theoretically we have dealt with. Now I would try to highlight as to how practically we can use these spatial operations, spread, extract, overlay, something like that. So here you see. So these you observed, so land use. So now this is 1980, 2000, 2020. This we have discussed. This is about land use. Now what happens? This is the land transformation. Now we have three time period data, 1980, 2000 and 2020. This example of overlaying different is about different time period land use map, and from these map, by overlaying these map, we are trying to draw change. We are trying to assess and present the change. We call it as change detection by overlaying. So here when we overlay spatial information, the system compare each polygon. If it is the same, then the system will assign as no change. And if there is change, then which land use to what land use is transforming, is assigned. Then there is also generalization, merge to make the data presentable and error free. And since we are using three time period data, so we will have two sets of transformation or change detection. One between the initial period and mid period. In this case, it is 1980 and 2000. So you see, within this period of 1980 to 2000, there has been some areas where changes have happened. Now specifically we know that from which land use class land is transforming to which land use class. So here you can see the whiter areas where no color is existing, it is no change. That means during the study period there has not been change. In the middle of the city also it is no change. That means it was built up, it was whatever land use class was previously, it remained afterwards also. So this is what the change detection when you overlay two time period data. So this is again interesting. Then it is between two time period, first two time period, this is but between second and third time period. Now you see, with time you would understand as to how the trend of transformation is coming up. You see, if I can go back to the previous slide, you see the colors are different. That means the land transformation which is happening, it had different pattern between 1980 and 2000, and here it is different. That suggests what? That it generally we explain these kind of phenomena without using spatial information, first period of time and last period of time. Now in spatial information, within the period, within the study period, how changes are happening, that can also be found out. Not only we can know the exact location, but also about how much and at what rate the transformation is taking place, at what rate the changes are taking place. That will also come. So in that context, I would say that this has great value, and when you analyze and examine it carefully, more minutely, then you can surely bring a lot many insight. You can explain how the phenomena is evolving, how the phenomena is transforming, how the changes are happening. Are there any pattern? Are there any trend of changes? That all can be done. So this is one very important and interesting aspect which you can bring into using the spatial information. Then you see, this is, I would say, is the total change between the entire study period. Again, the spatial dimension. So I would say that it's very easy to explain this particular image. But previous to that will give you the trend of change, pattern of change. And I would say that all three images which I have shown you, they will give you some good idea, some good insight into the trend and pattern and the kind of transformation, the kind of changes which are happening. And specifically, we know the exact location where a specific kind of trend, pattern or change is being observed. So that is what the advantage of spatial information when we use different data. Now, one more important point which I would like to mention here. You see, when I am saying that there are three time period data, three time period information. Now, these three time period information are drawn from different sources. For example, 1980 was Survey of India information. 2000 was satellite imagery. 2020 was satellite imagery along with ground truthing through Google Maps aided with GPS location. So you see, there are different sets of information, and all these information do not have in the same format. They all were in different formats. We have brought them all in digital format. We have brought them all in one set of coordinate system. This is, again, I would say, is a big advantage, a big utility of spatial information that you need to inculcate into your studies. Whatever discipline you belong to, but if you just visualize how the phenomena is appearing on the ground and how it is changing and what attribute is contributing to this change or existence of the phenomena, if we can depict that in the form of spatial information, it will certainly add value to your analysis. That's the point which I am making again and again. Moving ahead, you see, we talked about buffering. So this is a good example of buffer, or in layman term, I would say influence area identification. This is, in this particular exercise, again I am taking the same land use map, but what I have done, I have picked out important road networks with this hypothesis that the roads have influence on land use. So road has great influence. That's what I feel, that roads have great influence on land use. So the land use, the land use on the ground, it would be influenced by mobility and connectivity. So that would be one issue. And with time, the land value would be higher close to the road. So the land transformation would also be dependent on the good connectivity, mobility and proximity to the road network. That is what the hypothesis. So when you can do this, so you can find out that there are two data sets. One is about 1980, another is for 2020, and it is only about land use. Now we had the land use for the entire city. Now we are only concerned, out of the same information, we are concerned only on the land use along the roads up to 500 meter on both sides of the road. And we are getting some new information. The same information is drawn in some other way and it is being presented in a different way. Again, I would say this is an advantage of spatial information, where we are creating a buffer overlaying the land use and we are getting the influence area buffer along the road. So this is about the land use up to 500 meter. Now how the distance is contributing. So here you see, this is excluding the first 500 meter now. It is from 500 to 1000 meter buffer along both sides of the road. So you see, if you see here, the color would give you an idea, good idea, that how the land use existing is different. You see here and you see here. This is again, I would say, a good example of how another spatial operation that can bring new insight from the same data. My point here is that the same data, it is being redrawn, it is being represented in different format, and with this with this change in presentation, doing some spatial analysis, you can bring in new insight, new information from the other original data. You can bring some insight from the original data also, but these insights can be multiple time increase if you use the spatial information effectively to produce, to examine new how the phenomena is evolving. That will give us good idea. So this is again an example of it. And this is how the land transformation has taken place. So this is one land transformation along the 500 meter buffer. Another is on the right side, 500 to 1000 meter buffer, that is away from the city. So again, you can see and assess as to what kind of transformation is taking place. Now you just visualize yourself, you just think about these phenomena and you would come across that yes, there may be some issues, some attributes which would be contributing. Now when you find out, when you get idea about the attributes which are making this happen, how the changes are happening, then you can bring in these attributes into your spatial information, and then you can come up with new insight, many more insight into the same kind of analysis. That's another point which I wanted to highlight. Now, in this slide, I am trying to portray some example of spatial representation related to the planning. Now you see, we talked about land use. Another aspect of land use is its planning. Now, for the city which I did this study had master plans. Now, master plans are governmental document. They do not follow the scale. They do not follow all the mapping techniques and the basic requirements. Not necessarily they apply to that, because it's a planning document. They are not officially representing through a map. So it's more of a sketch rather than map. But another important advantage of spatial information science is that you can bring non-spatial information into spatial format by georeferencing them. So I georeference these sketch, and I come up with this kind of new information out of it. So this was the built up area, another was the university area, and there is one polygon which is for municipal boundary, and this another is the master plan boundary. All of them I have drawn from the original data. So new insight into it. Exactly, we know that how much area is under which land use class. Now what happens? Now I am splitting these data. You see, this is quite complex map. This is quite complex, which is representing many land use classes. You need to specifically look into each single land use class, and then you have to find out there. But when it is in spatial information mode, you can have individual information, you can represent them individually, and that will give you a greater idea about how you can represent it. Now, moving ahead. So these are land use classes, and important part is that the surrounding area is agricultural land. So the same information I have presented in different way, and some new insight would come very obviously. Now what I did, this is the master plan, and I tried to find out that if I overlay these land use plan over the existing land use, what is the status of planning? How effective is the land use plan, master plan in the city? So here, if you see, so this is developed according to the master plan. There is no change. That means whatever plans have been assigned certain land use class, it has not come up. So there is no change. So from these two sets of information, I have drawn some new insight into it. Now, moving ahead. Now this is violation. That means what? That means that whatever has been proposed in the plans, master plan, on the ground there is some other land use class. That means there is some kind of violation. Now exact location of violation we can identify and we can represent. And how much violation is happening, that is also possible now. Moving ahead. This much remained undeveloped. So that's another important issue. And then these are specific violations by specific land use class. For example, this is residential, this is for commercial, this is for industrial, this is for other land use classes which have resulted into violation, and this remained undeveloped. So that is what the evaluation of master plan. Now there is one more important aspect which I would like to add. This is about the speculative landholding. Now you see, this is the real picture of ground reality which I am trying to show. That means what? That means that in future the violation would be even greater. So this is how I would say, simply I have tried to give you some idea as to how you can proceed with any phenomena and try to find out some new insight using the spatial information.